we're going to review leveraging Amazon Connect recording capabilities to store a call recorded into an S3 bucket, which they'll will trigger an event from an SNS topic subscription that will then trigger a Lambda function that will initiate a state machine to retrieve the file, transcribe it, store some of that data into DynamoDB, grab the transcription and push it through Comprehend to understand the sentiment, and then store that sentiment into a regular database that can then be presented back to the agent for future reference and training. So let's give this a try.
Call recording behavior once this contact is connected to an agent. Note, any recordings will be stored in Amazon S3. Press 1 to turn on agent and customer recording. Press 2 to turn on agent. Hello, thanks for calling. Press 1 to be put in queue for an agent. 2 to securely enter content. 3 to receive a link and update your account online. 4 to request a call back. 5 to set a screen pop for the agent. 6 to roll the dice and simulate. Thank you for calling. Your call is very important to us and will be answered in the order it was received.
I am extremely angry with the service. So now a new file just dropped because the subscription down was triggered and this Lambda function was executed. The step functions are now initiating a brand new job running that will then persist the data into a database, to a DynamoDB database, after it has created a job, as you can see here, to transcribe. So the workflow has already executed all the way through where the voice was recorded, dropped into an S3 bucket, the subscription to the topic executed, the Lambda function that triggered the step functions that now are initiating the process of pulling the file and then iterating through and polling the transcription job until it ends, as these other ones. And once it ends, this workflow will execute all the way through the Comprehend Connect customer and then update the customer database. The end result looks like this. Let me just pull one that has completed while the other one is running. And so it goes through and we tell it the job to transcribe that is running. We pass that along the steps of this step function, and as we go through the steps, eventually the transcription is executed, and it tells that the job has completed, and then pass the value to Comprehend that then tells us the sentiment. Now, for such a short voice recording, the process to get it all started is pretty quick, but the process for the transcribe job to take that audio file and transcribe it and then generate a file that actually contains the transcription that we can then use to pass to Comprehend takes quite a long time, upwards of 5 minutes, for a 5 to 10 second transcription job of an audio file recording. The outcome will be the same as this one that I just ran a few minutes ago, so I'm not going to sit here and wait until it completes. It's still running. You can, of course, stop it and avoid the charges if you're just running some tests. But at the end of the day, it will execute the moment that the transcription job completes and it turns green. This will progress through the rest of the steps. So it started, he captured the recording at 3:24 p.m. today. Actually, no. What is it? 4:13. Sorry, 4:13 p.m. He went and created the transcription job at 4:13:18, almost immediately, right? So that means that the subscription picked up the event, and in a matter of less than a second, executed to create the transcription. And now the job, if I refresh here, has ended. CEAA9, the job, the state machine that was running has completed execution. And if you look at the job, CEAA9 is what completed. And when I look at the comprehend customer, the output, this one, of course, with my accent, the transcription gets confused. And so instead of angry, extremely angry with our service, because he found the word agree. He thought it was neutral. On the previous iteration, he picked up the word angry and he found that it was negative. And that's it.